All right. Sorry, it took a couple minutes longer to set some things up than I thought because my math lab wouldn't let me in. All right. So today is the 25th. Your homework due dates are up there from what is currently, what has previously been assigned. I'm keeping the read the next 1 to 2 sections a little more vague this time because we're going to talk about the project today. We're going to talk about the midterm today. So there's a lot more random talking. I'm not sure how far we'll make it through 4.2, 4.3, 7.1, exaggerating there, obviously. Your next Excel file is right here, 2.4 CPI. Now, I want to make sure that with this file that you know what it should look like, because in the past, for some reason, people don't understand that they can move left and right in Excel. So I just want to pull that one up really quickly. All right, so usual, when you open your Excel file instructions, then there's another tab for the questions. So when you open this up on your computer, depending on the size of your monitor, depending on your defaults and everything, what some people will see is that it might look like, hold on, this. Like you may only see this right here, and then you scroll down, you're only going to see the table, but you can scroll left and right. And when you do it that way, it goes really, really fast. I didn't mean to go that fast. But the instructions are over here to the side. Now, what I've also seen, as well as an extra couple of blanks here and some more instructions, what I've seen occasionally, and I think they fixed this in the last semester, but a year ago, it would open up to just here, and students didn't realize that they could move left. So I just wanted to, again, put every bit of information here on the screen for you. This is a CPI table, CPI, Consumer Price Index. We said that we just used those proportions, a fraction equal to a fraction. And again, they give you instructions. What I would suggest with this assignment is to do it by hand first for just one of the blocks. Again, follow instructions. Use the annual CPI values to convert the given cost of an iPhone in 2017, and it tells you the cell, 0119, into every other year's dollar. This is assuming that the iPhone 8 existed back then. So it's kind of a joke. We're going to take this thing all the way back to 1913. Obviously, the iPhone did not exist 100 years ago. But we are going to still find the equivalent cost of an iPhone in that year based on all the CPI adjustments. So we have the price in 2017 dollars all the way down here. So you're not going to work from the top to the bottom. You're actually going to work from the bottom to the top. There's nothing that says you can't do that. So you're using your CPI values, and they tell you to use the annual ones. They give you all the monthly ones over here, and then the annual one, I guess, is just like a type of average for it, right? Probably. Sounds good. So you're not even going to worry about any of these numbers over here. It's just bloated extra information. You're only worried about these. So these are your CPI values. Well, look at this. Here's a box with 3 corners of numbers and a blank, so you could set up a proportion using those by hand, maybe use cell references or the numbers, whatever you like, and then you can solve for this one. But remember, when you're typing this in Excel, you're doing formulas. It's not going to be equals and then 240 over 245 or anything like that. It's equals and then cell N118 over N119. And again, I'm not telling you that's what it is. I'm just giving a ballpark example. Or maybe it's N118 plus N119. It's not plus. That was me whispering to you if you didn't catch that. So again, this is just a proportion that you cross multiply and solve, and you'll get something like equals C5 over D2 times A1. It's going to be something like that. And then you can just fill that formula up. You should only have to type it once. Now, maybe you need fixed cell references, maybe you don't. I'm not telling you, and I'm not even giving a hint there. Maybe you can do it without, maybe you can do it with. When you're asking yourself, do these answers make sense? If your iPhone all of a sudden goes from $700 to $10,000 immediately or $2 immediately, that wouldn't make sense. If it's $700 in this year, it was probably like 680, 690, 695, I don't know, somewhere in that ballpark the previous year. But the price should be going down as you move backwards in time, because that's how inflation works. Things go up as you move forward. If you pretended to go backwards, they'd go down. Okay, so I just wanted to mention a few things about that because historically some students, a lot of students just kind of have difficulties thinking about going backwards instead of forwards, but it's really the same idea. And again, just the fact that you might have to zoom in or out or may have to move left or right inside of that Excel file. All right, but you got your due dates for that. That Excel's due on the 30th. Project discussion today, midterm discussion today as well. I don't have a date for the midterm yet. I will have that on Tuesday. I am 99% sure. It's just a matter of how far we get in 4.2 and or 4.3 today. I will talk about the next discussion board. Remember, we gave a quiz last time. It's a one-question quiz. It should be easy, I hope, if you follow it along with the notes from last lecture, the examples I was doing for us. So that's due today. The posting by 5 p.m. is no longer relevant. It's already there. I saw that someone emailed me this morning asking about when am I grading quote assignments, and I think they meant the quiz. That last quiz, those of you who did it early on, I actually went ahead and gave you some credit because the answer, I don't want to spoil it in case someone tries to go back and turn in late work, and I don't remember how everyone's done so far. But some of you actually like typed in, you should set up this way, blah, blah, blah. You actually wrote out words and instructions like it was a discussion board, and that's excellent. But unfortunately, it gave you a 0 for the quiz because my answer was just something like, $5. That's what the answer was basically something like. Again, I'm not spoiling the answer. It wasn't in dollars. So if you had that answer right and you typed in extra instructions and it marked it wrong, I will go back and give you full credit for that. But the quantitative student bit I was talking about was some people just put numbers, some people put numbers and labels, and I really emphasized that in the last lecture. So anyone who caught that lecture before turning in the quiz should have realized that that's what I was expecting. So I won't give you full credit if you just wrote a number, but if you wrote a correct number and correct units, and if the quiz marked you wrong, you will get credit back for that. But I can't think of any other assignments I'm supposed to grade besides catching up on the discussion board. So if there's something else that I need to look at, shoot me an email and let me know. Just be more specific, please. But again, any quiz updates should be done no later than 5 p.m. today. I'm hoping to look at the discussion boards. I actually have a free afternoon for the first time in quite a while after I teach my second class. So I'm going to be able to catch up on a lot of details. All right, so there's your usual due dates and such. We're not doing this yet. I'm just going to scroll down to where we need to be, since that's what popped up next. Here we go. And I know this says spring. Ignore that. This is for summer. I have changed some things in here. And I'm going to upload this in Canvas again today by 5 p.m. The due date is still to be determined. I do have a ballpark, though. Let me pull my calendar out because I don't have all the future dates memorized in my head. I'm thinking July 21st. I'm thinking July 21st, and I'm putting an asterisk, 4 asterisks, asteri, next to this for now, because this is tentative. If I think I need to change it, I will. But I don't think I'm going to need to change July 21st. At worst, it'll be July 23rd, but our last week of class is after that. So this is later than I'd ever have the project due normally, but this is a very, very weird scenario. It's summer class instead of fall or spring, as well as the unique teaching style, and just probably being behind by about a week at this point now between the weird lecture and missing a class. So there's two parts to this. Part one is worth 60 points. So if you nail the actual budget itself, but you don't do the other part, the best you'll get is a 60 out of 100. You're going to get a high D. Part two is 40 points. So if you only do part two and you don't do part one, the best you're going to get is a 40 on this assignment. And this will be a hand-graded assignment. There's no auto-grading for this. I can't imagine how that would even be possible for me. Looks weird. I think that's a typo. Whatever. So part two is actually ridiculously short, but I will point out that it's pretty easy to mess up part two, but let's get to that when we get to it. Each student is responsible for creating a monthly budget of all their expenses for the month of, again, I didn't change a couple details here. And we're going to do this. We're not going to be able to have a full month. Actually, if I keep going back and forth on what I want to do. I wish I had assigned this one class earlier. Yeah, let's just call it the month of June 29th through, and then July 20th. So it's almost a month. I would love to actually be able to give you till July 29th so you'd actually have a full month, but I know what's going to happen is most students aren't going to have the rest of the project done at that point, and everyone's going to be scrambling to do all of this 2 seconds before the final exam starts. So I'm just going with a slightly altered version of this. So we'll start on the why am I doing the 29th? Today's the 25th. We're going to do the 26th. Let's get that almost month. I don't know why I transposed my 6 into a 9. I don't have dyslexia. That was weird. Okay. So you are going to document all of your expenses for the quote month of June 26th through July 20th. So we're 5 days short of a true month, not the end of the world. If you do not spend money regularly, because we're students, right? Some of us, maybe all of our money is just coming from our parents. Maybe some of us just really never, ever buy anything, and they're doing all the purchasing and you don't even see the numbers. You're just behind a veil. I don't know. I know very little about your personal finances for obvious reasons. So you will need to ask your parents or spouses or whoever it is that is doing your budgeting, your expending and stuff, what they're spending on you each day. Now, I want to point out ahead of time, I'm not some nosy teacher that's trying to get in your business. I don't want to see anybody's expenses and just, oh, well, Bob's spending too much on this and Jane's spending too much on that, or Alex is doing a great job. That's not what I'm looking for here. There's no judging. There's no analyzing of your details. In fact, when I grade these, they're going to be, I have a way I can open them randomly without actually seeing your names, unless you type your name inside of the Excel spreadsheet. So that's one thing to pay attention to. If you don't, because I plan on grading these randomly, I won't actually see your name when I open the Excel file. But if you put your name inside of the Excel file somewhere, then I will know. And if you don't care, that's fine, but I don't need your name in the Excel file anywhere. I just need it on the file itself, like when you go to open the file. So like, oh, here, Beckner CPI, that's where your file name is, Daily Notes Summer 2020 - Rodney Beckner, something like that. That's where your name needs to be. When you upload it to Canvas, your name's supposed to be put in there automatically, but I still like people to upload it with their name already, just to be safe. So again, I open them randomly, I do the grade, I write down the numbers, and then I go back and I cross-reference what the original pulls were a day later, so I don't remember who was who, but I have all grades recorded appropriately. So again, not trying to get in your personal business. Again, if you don't spend your money regularly, hopefully your parents or spouses or whoever, they don't mind sharing that business with you. Some people are very, very wary about sharing anything financially, not just between friends, maybe even family members. And, you do you, that's okay. My belief is that we don't talk about this stuff enough, that we should be a little more open about it, but I'm not going to force my beliefs on anyone else. So if you have a parent or spouse who just says, no, I'm not going to tell you what we pay in rent every month. No, I'm not going to tell you what your food costs every month. If they're going to be stingy with that information for their belief system, whatever, then make up your own numbers. So make up your own, absolutely necessary. So you can just say, I think my food is costing me $10 a day. I think my rent's $500 a month. I think my water bill is $40 a month. And let's say you live with your parents and the rent is $1,500 if there's 3 of you. You could say that your portion of the rent was $500. You can do what's called prorating, which means I took that $1,500 and divided it by 3 people, $500 a person. So you could do something like that. Now, when you set this project up, you are starting from scratch. This is not like the Excel files for the Excel homework. This is more like the very, very first one we did, which was based on that chapter 0 guided worksheets and textbook. Except the difference here is I'm not going to drag you by the nose, so to say, and show you, hey, put this information here, put this information there. You have to create everything from scratch. But I do at least give you some ideas on setups. All right, and I don't know what it is. The past 2 semesters I've done this, I have a lot of students who still can't understand what a row and a column is. Rows should be the days of March, again, days of June, July, the ones that we're supposed to be doing. Columns should be the different categories. So you want to categorize your expenses, and I'm going to talk about those categories in just a bit. So you could start here and go June 26, June 27, and it might format it that weird way. That's okay, there's nothing wrong with that. You can even probably fill this down somehow until you get all the appropriate days up to July 20th. Then up here is supposed to be your categories, so maybe rent, food, etc. This is how it should be. If you put the dates up here, if you put June 26th here and then June 27th here, and you put your categories here, if you go rent, food, if this is how your table looks, you are going to lose points. You will be penalized for that. I don't want it to look that way. Now, I'm not saying that someone couldn't make a spreadsheet that looked that way, but we'll be able to fit a lot more information in one screen doing it this way versus the other. So that's why I'm suggesting that format. The furthest right column should total your daily expenses. The furthest right column should total your daily expenses. So after all your categories, maybe your categories go up to here, this should be the total column, and it should total, it should sum, I'm giving you a lot of hints here, the entire day's worth of expenses. Now let me tell you how people do things wrong. Let's say you spent $500 on rent here, and then you got your total column here. If you type 500 here, that is wrong. You are supposed to be using Excel. Because if you do that, that means for the next day, you're going to have to type the total. For the next day, you're going to have to type the total. If you have different columns that you're adding, you're going to have to add them. Make Excel do that work for you. And don't just add, okay, well, I only see a number here, so just go equals in that cell. That would be wrong. That would be wrong. That would be wrong. Even if there's a cell blank, you need to account for it. You're supposed to be summing them. This should be a formula that looks the exact same for every single row. If you're going through and typing different formulas for different rows, it is wrong, 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 and you will be punished, punished, punished in terms of points. So I say, I don't really want you to have more than 20 categories. Now, if you want to do more than 20, that's fine. I've had students turn in 25 or 30, and I did not punish them for doing more categories than, I said, maximize at 20. But this is just to try and kind of curb things because some of you might have tons of expenses. My TCC students, we vary wildly. Some of us parents pay for everything because we're 18 or 17 or 19 and just getting into the world. And some of us are 45 and 50 and have kids and maybe grandkids and homes and maybe rental properties and all sorts of things. The importance of this project is for you to kind of learn what you're spending in a month, and that, oh, maybe I'm spending a little too much here. Maybe I'm not spending enough there. It's usually I'm spending too much on something. And those categories are usually pretty common, like fast food, cigarettes, things like that. And that's what I'm going to get into an analysis part later. So if you think you have more than 19 categories or more than 20 categories, just go ahead and call the 20th one miscellaneous, and then to the side, you could just label that. So let's say, here's our miscellaneous. And then let's say I had a miscellaneous expense of $27 this day. Over here, I could just have a little note and say, this miscellaneous expense is, I don't know, a haircut. If you don't want to label your miscellaneous expenses, you don't have to. I'm not going to take away points if you don't label a miscellaneous expense. That's more for you. Again, this project is not for me. This is for you to grow in a financial way. You can label one column for just food, or you could have a column for groceries, then a column for fast food, then a column for dining. But I don't really think you should have columns for each and every fast food joint that you visit. Don't have a column for Panda Express, a column for Moe's, and a column for Burger King. Just have one column for fast food, and that would be good. I do have a minimum number of categories. I need a minimum of 6 categories. If you do not have 6 categories worth of expenses, once again, make it up. Just make it up. Now you might say, well, Mr. Beckner, if I'm making up my expenses, then how is this going to benefit me? Well, you'll understand how to build this monthly budget. When you actually have to do this, you'll already have something set up, and you can go ahead and put in your real information at that point. You can also go online and find very common breakdowns for people's monthly budgets. If you ever have to go to, I don't want to get into that detail. Never mind, that's not worth it. Sorry. This part right here, I will admit, I used to just do this as the entire project. This just used to be the entire project. Well, there used to be a different part 2 is what I should say. There was a slightly different part 2. But no one ever did this. No one ever did this. Out of the hundreds of students, I think I saw one student actually handle prorated expenses. This is something extremely important in your life. Not only just, oh man, in January I spent $800 this month. In February I spent $750 this month. Our budgets don't always end up flowing so nicely. Maybe in March, your car breaks down and it's a timing belt issue. So they got to go in there and they got to replace the timing belt, and you say, well, all right, you're already down there. Why don't you go ahead and replace the water pump? And they had to go through your wheel and through your engine bay to do all this. And of course, the repair people are going to charge an arm and a leg, and you're $1,200 in now. January was $800. February was $750. March, $1,200 just on one single expense. Then your other $500 or $600 or $700 worth of expenses. Holy cow! What happens? Do you put it on your credit card and then all of a sudden just start, paying 22% interest every single month on that till it's paid down? Do you not pay some other bill and hope that they don't shut off your power or water at some point? Unfortunately, this is what a lot of Americans do. And if it's what you absolutely have to do, it's what you have to do. But there are many cases where people could plan ahead and think about, well, you know what? I know my car is not going to run perfectly every month. Maybe I should set aside $100 a month or $150 a month or $50 a month, some dollar amount. That way, all right, January, I put my 100 away. February, I put my 100 away. March, oh, I got my $1,200 bill. Well, at least I got 200 put away and now it's only 1,000 left. Maybe you were able to do that for a full year before that expense hits. $100 a month times 12 months, boom, your timing belt and water pump are paid off. You never have to pull out that credit card and pay 22% a month. You never have to hold on to that electric bill and hope they don't give you a final notice or just flip the switch at some point. So this idea of prorating an expense, that doesn't happen every month. It doesn't necessarily happen constantly. You know, some expenses happen every 6 months or a year. Car insurance, for example. Car insurance usually comes every 6 months. Now, a lot of places will give you the option to pay it monthly, but then they usually charge you 10 or 15% more. What they like to say is they give you a discount if you pay it 6 months at a time instead of 1 month at a time. So if you want that discount to have those long-term savings, kind of like the protein problem we did, that was me clicking, sorry. If you want long-term savings, then you want to pay your car insurance 6 months at a time. But if you're the average American who just keeps $50 in their checking account, when you get that $360 insurance bill, you freak out. You go, oh, this sucks. I got to pay $360. But the other person, the American I try to grow and cultivate, says, hey, my insurance bill is due in June, so in January, I put $60 aside because that's what 360 divided by 6 is, because I'm going to think about my 6-month based expense 1 month at a time. So in January, I take $60 and I put it in a special spot. February, I take $60 and I put it in a special spot. March, April, May, and June, I do that, and then when I get the $360 bill mid-June, I have my $360. I never have to worry about oh man, I was never expecting this expense. But you should have been expecting the expense. You know it was coming. Set aside for it ahead. Vehicle property tax, that's another one. $240 a year for, I don't know, maybe that's like a 2018 Jetta or something like that. That's probably in the ballpark of $240 a year. If you've got like a 2006 Civic, you're probably looking at like $80 a year, because the more valuable your car, the more property tax you pay. So your $240 check that you have to write in June or May or whenever that check comes, I feel like I just wrote mine, but I honestly can't remember. Maybe I wrote it in April. Either way, not the point. So when I have to pay my, I think it's like $120. I've got a middle-aged car at this point. Maybe it was 150. Either way, when I have to think about that, let's say it's 150, I go, okay, well, 150 divided by 12 is 12.5. So I'm putting $12.50 every month into some, quote, special place, whether it's a separate account or it's just on the books as somewhere, or it could be literally under your mattress if you want to go with that classic example. So I take my $12.50 and I put it aside every month, and then when that bill comes, I've got my my $150 ready to go. So some expenses are completely expected. You know this bill's coming once a year. You know this bill's coming twice a year. You know this bill might be coming quarterly. If you own your own home, then instead of your property taxes for the home being put into your mortgage and an escrow account, so you don't just pay the bill, you pay your taxes and insurance in there as well every month. They prorate it for you. So once you actually own your home, you no longer have this escrow account, which is what it's known as. So you have to pay your taxes as the actual bill comes, which is quarterly. Quarterly means 4 times per year or every 3 months. So let's say that your property taxes were $400. That's very, very low. Your property taxes are much higher than that for a home. But let's just say they were $400 for the, I'm sorry, $300. I want to do a nice round number. $300 for the quarter. So if you paid $300, I don't want to do this on there. If you paid $300 per quarter, now you have to be careful here. You might say, oh, we'll divide this by 4, but there's 3 months in a quarter because there's 4 quarters a year. So you divide it by 3, and that means that you're paying $100 per month. Now, when you had that escrow account, this $100 a month was in your mortgage payment, but now your house is paid off and you will no longer be paying $100 a month. You're going to pay $300 every 3 months. So again, you could just think about putting $100 aside every month to account for that so that you're not freaking out and paying $300. Your homeowner's insurance is probably going to be like $1,000 a year after you own your home. oh man, where am I going to pay this $1,000 bill that just came up all of a sudden? Well, no, that's like, 80, 90, $100, something like that every month if you set it aside appropriately. There's a story I'd love to tell about someone. You know what? I'll tell it. There's a. I don't want to say I knew someone. I know of someone who outright owned their home. It was passed down through their parents after they passed, and they didn't put insurance on their home. Now you might say you have to have homeowners insurance. This is true if you have a mortgage. Once you own your home, at least in Virginia, you legally don't have to have homeowners insurance anymore. That doesn't mean anything. Continue to have your homeowners insurance. Always have homeowners insurance. That is the number one thing you need to pay for. So this person who owned their own home, I guess they weren't really worried about it. So they didn't have homeowners insurance, and their house burned down and they lost everything. They started from scratch. It was gone. Not one penny. Do not make that mistake. I hear a lot of stories about people who get these generational homes, their parents or grandparents pass it down to them, and then because their real estate tax bill is coming separately and it's coming every 3 months, they say, oh, I can't afford that. And then 3 or 4 years later, they get this $10,000, $15,000, $20,000 bill, and the city says, you need to pay this now or get out. And there you go. You just lost your home because you couldn't handle a non-prorated expense. These are things that could be important in your life. And most of us don't have homes passed down to us. Most of us are going to have to earn them ourselves, but at least ultimately after you pay your home for 30 years, these are things that will be part of your life eventually, unless you rent all your life, and that's okay too. All right, see, I have to rant a lot about this project because this is super important to your life. This isn't just about math class, this is about your life. And nobody says this stuff in high school, unfortunately. So again, this is something I would like you to try to account for in your budget. So maybe have a column for if you're paying your car insurance every 6 months, have your prorated car insurance payment somewhere. That would be really, really good. But not all expenses are predictable, like your car breaking down. We don't know that our car is going to need a water belt, excuse me, a water pump and a timing belt on March 31st of 2020. But we do know that there's going to be an expense on our car at some point, which is why it's suggested to account maybe somewhere between $50 and $200 a month of car expenses. And that's excluding fuel, that's excluding your car insurance. That's just repairs, tires, oil changes, things breaking. And you might say, well, 50 to 200, that's a wide range. Yeah, because we drive a wide range of cars. If you drive a clunker that's actually reliable, like an old Civic, maybe you only need 50 to 100 a month. If you're driving around some BMW M5, you probably need to be putting 300 a month away for your car expenses. Because an oil change in that car, you probably have to take parts out that you wouldn't have to on another car because of the engine bay and blah, blah, blah. You get the idea. I mean, there are literally hundreds and hundreds of categories of expenses. Come up with as many as you can. I want you to I don't want to say be creative, but just dig deep. Again, I need a minimum of 6. If you're not going to prorate them, you're not going to prorate them. That's okay, because I'm going to force you to do some prorating in part 2. All right. So part 4. And basically, these 6 parts are 10 points a pop, roughly. I say roughly because the analysis, I don't necessarily have to count that as 10 points, but I usually do. So your 4th part, your last row should be the sum of each category. Row, remember, rows are horizontal. So we said our days are our rows, so we need a row down here, and that's supposed to be the sum. So you'll have a sum for each category. So if you spent $5 on food the first day, $10 the second day, $3 the third day, you didn't buy any food for a couple of days because you bought a bunch of groceries somewhere, there should be a spot down here that adds all of those up for every single category. Remember, filling formulas, this shouldn't take too much. A person who understands Excel could fill out the skeleton of this thing in about 5 to 10 minutes. You just have to then go and put your numbers in. And you could all go ahead and create your entire skeleton for those 22, 23, 24 days right now, and then just fill in the numbers as you go. Or maybe you go, oh, well, I need a new, maybe you wait on the total column or something like that. because, oh, okay, well, here's a new column, here's a new column, here's a new category, whatever. Then I want you to create a pie chart. I'm not telling you which specific pie chart to use. Use one that you like. Don't use the weird ones. Don't use the ones that have like separate parts. Make it a pie chart. But this should include every expense category, not the sum of the daily expenses. So this is using the sum of each category, not the sum of the daily expenses. So part 5 is based on part 4. If you don't do part 4, you can't even do part 5. That's 20 points gone. This should show you each expense as a percentage of your total expenses. Make sure the chart is labeled appropriately. I need to see the percents. I need to see the category names. If the category names are 1, 2, 3, 4, 5, you're not getting full credit. If I don't see the percents, you're not getting full credit. Then somewhere in the chart, make an analysis of your monthly expenses. By analysis, I mean, I've spent too much on Chick-fil-A this month, or I didn't put enough away in my savings account this month. I don't need to see your bank account balances anywhere in here. This is just a total of daily expenses. So where do you have to put the analysis? Just make sure it's on the screen somewhere I can see it. Don't put it 20 million rows or columns away. So here, I spent, I could say something like, after seeing how much I spent over a month on Chick-fil-A, I realize how my daily expenses add up, and that I should maybe cook at home more often, or maybe go to YouTube and look up a Chick-fil-A recipe. You know, do your pickle brine, do your batter, blah blah blah, and just make your $4 Chick-fil-A sandwich at home for like $1.25 or $1.50, something like that. And I just like to pick on Chick-fil-A and Starbucks. It's just my two choices. I know there's plenty of options out there. So again, make sure you're doing all 6 of these parts. Every part is probably 10 points. So missing something, it's going to hurt quick. So 60 points comes from that. Now, 5 years from now, 10 years from now, do you have to use this as your monthly budget? No. There are plenty of pre-made budgets out there on the internet. Do not use them for this homework. If you use something that's pre-formatted, I'm going to know. And you might get a 0 for it because you're not following instructions. But again, in the real world, those are great opportunities to use. Okay, part 2. And part 2 is 40 points. And again, I will upload this to Canvas this afternoon. You will be assigned a specific set of expenses. See the Excel file in Canvas on different periods that you must prorate to monthly expenses. You are to then add all prorated expenses to the provided, quote, all normal monthly expenses, food, fuel, activities, etc., to come up with an average monthly expense. I gotta find this file. I forgot to open it. Should be in here. Does it not want to open? That's weird. Let me close this and see if that helps. That's weird. Okay. Good guess, Rodney. Okay. So this is the file I'm referring to, which will again be put in Canvas for you. Now, these A, B, C, D, this is Bob, this is Jane, this is Alex, this is, you get the idea, Mason, anything. You got 8 people's different names. These are expenses that I made up. So Bob, he pays $1,000 a month for his mortgage. He pays $150 every year for his property tax on his car. He pays $420 semi-annually. Semi-annually means twice per year on his car insurance. Now, when you're prorating these, all you're going to be doing, literally the whole thing you're doing for this is dividing. You're dividing by a number. So, $1,000, and this is paid monthly. I'm not saying you pay I'm saying you pay $1,000 a month here. This is already a monthly expense. There's no prorating of this to do. If an expense is monthly, you don't have to prorate it because you are prorating these to monthly. Let's see if I can get the instructions and the file up at once. Boom. You will be assigned a specific set of expenses. So I'm going to shoot you emails, and in your emails, I will say, you're person A. So you would only use this column. You would completely ignore all the rest. And what I would suggest you do is delete the others like I just did. If you're column A, do that. Or maybe I say, all right, in your email, you're person D. So then you are not looking at any of these. You're only looking at person D. Okay, so you'll get an email today with your assigned person. I think there's 9 of us in this course, so there'll be 2 A's or 2 E's, but it's almost enough for everybody to have their own person. But you won't be communicating with each other about this, so it's not like that matters. Oops, I didn't mean to click that. So you must prorate to monthly expenses. So anything that's already monthly, don't you dare touch it. You are then to add all prorated expenses to the provided all normal monthly expenses. That's here. So this all normal monthly expenses, this is just everything else like food, fuel, activities, etc. That's not up here. So this would be like the non-prorated expenses from your monthly budget if you were using your own numbers for this. But again, I'm not asking you to use your own numbers for this. To come up with an average monthly expense. So you'll have to add a row here. This is where you would add everything up. So you can write sum or total for the month, whatever, and you're just adding everything for the person A or person C, whatever it is. But again, you're not adding just these. You're not adding just these. You have to prorate them first. Some of these things are going to become smaller numbers. You're paying $420 twice a month for car insurance if you're person A. That means you should be paying less than that every single month. You've got to think about how many months are in half a year. Home repair, $400 every quarter. So you got to think, all right, how many months are in a quarter of a year? And that's what you divide by. Annual expense, you got to think about how many months are in an annual, that means in a year. And you'll see that these numbers vary quite wildly from person to person because that's exactly what I would expect from us. Person E, they've got a really, really, really crazy house or something, or just a bad interest rate. They're paying $3,200 a month. Person A is only paying $1,000 a month. Well, maybe person E is making 100 grand a year, 150 grand a year, and person A is only making like 40 or 50 grand a year. So this would be more appropriate to their budgets. Property tax on their car. Person C's got a dash. That means they don't own a car. They don't have car insurance either. If you don't own a car, you don't have car insurance. So that's nice. Textbooks, person B and D are blank. That means, well, they're not in school. Car inspection. Well, look, person C doesn't have a car, so that's blank. You might say, well, man, person C, whoever gets C has got this really, really easy. Not really. It's not that much of a difference. They also don't have car repairs. New or used phone. So some of these people are paying $100 a month for their phone. Some people are paying $300 a month for their phone. Some people are paying $80 a month for their, I'm sorry, a year. I don't know why I said a month. Please excuse me. Some people are averaging $100 a year for their phone. Some people $200 a year. Some people $80 a year. Some people $300 a year. So person G is going out and getting a new iPhone every other year, maybe, whereas person F has had the same flip phone for 4 years, maybe. And again, you don't go out and buy an iPhone for, $200. You buy it for like $1,000 or $700. Now, this is partially true. I know they have those payment plan nows with, what is it, Apple Care, Apple Pay. I don't know. I don't do that. I buy used phones on the cheap. But that's because I'm a teacher. I'm not making 150 grand a year. All right. Vacation. Oh, person G, nothing. That breaks my heart. Please, when you have money, find some way to save for vacations. Vacations are going to save your soul. If you can't, you can't. I understand. If you got 5 kids and you're struggling to make ends meet, then you can't vacation. But hopefully one day you can. Whereas person H, look at that, $6,000 a year for vacation. They're going hard. And you can see some variation. You might say, oh, maybe this is the richest person up there. Well, they only have a $1,300 mortgage, whereas person E has got a $3,000 mortgage and a slightly smaller vacation budget. Person H has got this $1,300 a month mortgage with $6,000 a year to vacation, whereas person B has got $1,500 in a mortgage every year, but half as much for the vacation. Person C, $1,250 for their mortgage, but they're only putting $500 aside every year for their vacation. So these numbers don't have to be flush with each other. It's just that person H values vacation a lot more than a home. If they didn't, their mortgage would probably be closer to like $2,000, and then this vacation would be down at like $2,000 or something, or $1,500 or $3,000 even. I don't know. But you do get to choose how your expenses lay out. There's nothing that says your vacation fund needs to be 7% of your expenses. Your rent needs to be 30% of your expenses. Your student debt needs to be this. There are suggestions out there, and in fact, one of them is a highly suggested number of 30% for your rent or mortgage a month. Most people should not go over that percentage. But if you choose to, hopefully you can account for that. So again, you're only going to get one person. This will be assigned later today. Start this stuff as soon as possible because the midterm's coming up in like a week and a half, 2 weeks, something like that. You'll get a review. You'll get a study guide for that. You'll get a couple days to take the test, and we're going to talk about that in a few minutes. The couple of you that are here, if you have any questions about any of this, please let me know. Besides that, if you're catching this in post, please email me if you have any questions. Please communicate about this project if you have any questions. But make sure, at least if you do have a question, rewatch this first because the answer is probably in there somewhere. Let me show you what I want from, let's just say I assigned you person A. Oops, delete. That didn't work. One more take. So I assigned you person A. You could have a column for prorated. So then the monthly. And you're going to have to type a different one for each of these. You can't just do something once and drag it down. That's not possible. You do have to actually go through and do a formula for every single one of these, which is why it's 40 points instead of just 10 or 20 points. That's not to say that some of these aren't the same. These are both semi-annual. So in fact, because they're back-to-back, you could actually drag them down. These are both you got 3 annual expenses in a row. So you could type a formula here and drag that down. But when they're not the same back-to-back, you have to do a new formula. And these are simple. It's just equals this cell, then divided by a number. You just have to divide by the appropriate number. Make sure it makes sense. And then down here, you have a total. Oops. And then this is where you would sum it up. You would just add up all of these things. All right. Don't save. So that is our project. And once again, this will be uploaded in Canvas today, no later than 5 p.m. We're giving a due date of July 21st for now. You might say, well, Mr. Beckner, this is awful. How am I supposed to do all this if the expenses go up to July 20th? Again, you can build the entire thing while you're putting in your daily expenses. So then once you put in July 20th, the only thing you have to do is make your pie chart after that. And you can go ahead and have the pie chart set up ahead of time because as you, dang it. If you just, when you go to make your pie chart, let's say this is me highlighting all of the days, including the ones I haven't even typed. If I go ahead and make my pie chart, see it's blank right now, but as I go and type some numbers in, maybe this would be filled out. Now, this is a weird, wacky way to have done the pie chart. You definitely don't highlight all this information. It's only one row or one column, as the instructions have said. So there's the pie chart originally for this one. There's 3 things. Let's see what happens if I put a 7 here. Look at that, the pie chart updates. Look what happens if I put a 9 here. The pie chart updates. You can build everything before you put in all your expenses. It's absolutely possible. The only thing you'll have to do on that very last pair of days is put in the July 20th expenses, and then that's the point where I'd say make your analysis. You could probably go ahead and make the analysis sooner. You probably know what's happening 2/3 of the way into the month. Okay. Before that, midterm. This will be on chapter 1 through 4. It's going to be 20 questions. You'll have 2 hours to take it. You will get 2 attempts. The best attempt is kept. So if you get a 50 the first time and a 90 the second time, you get a 90. If you get a 90 the first time and a 50 the second time, you get a 90. You will have 3 days to take it. Say we finish 4.4 on let's say we actually managed to finish 4.4 on Tuesday the 30th. I'm not promising we're doing that. I'm saying let's pretend we are for now. The midterm would run the 8th, 9th, and 10th. This is 1 week and 1 day after we have finished the material for it. So in a traditional class, I always do my tests exactly 1 week after finishing the material for it. So if we were to finish 4.4 on that Tuesday, and again, I'm not saying that we will, I'm saying that I hope we do, then that is when the midterm would be. If we finish it 4.4 on Thursday, which is the 2nd, midterm would run I'll actually give you the 10th through the 13th, since it's over a weekend instead. So that's a Friday, Saturday, Sunday, Monday. So that still gives you 2 regular days and a weekend. I don't know which it's going to be yet. I'm giving you the 2 options, but it's definitely going to be one of these. There will be a study guide for the midterm. It will be about, I think I had this as like 55 to 60 questions. And then questions in the actual midterm will reflect these. If it's not on the midterm review, it won't be on the midterm is what I'm saying here. I think that is more than fair. I don't want to just give you, hey, here's 20 questions in the review, here's 20 questions on the test, and those are all the same. This is QR. This is not the time for that to happen. So you're going to get a pretty wide pool of questions for the midterm. That actually sounds too high. I don't want to pull up the midterm review right now. Well, I still have to finish it because I'm going to modify it from the last semester. It just sounds, that sounds a little high. I'll come back and change this as we continue discussing the midterm if that's a little high of a number, but you get the idea. You are allowed a calculator. You will need a calculator. There will be a formula sheet provided for specific versions. Nothing about time. What in the world? There we go. No other formulas. This is just going to be something like 1 inch is 2.54 centimeters. I'm not giving you actual formulas for chapters 1 through 4. We have not seen any crazy formulas at all. They've all just been multiply this, divide that, or add this. The only The only slightly complicated formula we've seen is the weighted average formula, and that's just multiply and add a bunch of things and then divide by adding a bunch of things. That was back in section 2.2. When we take the final, when we deal with the crazy finance formulas, you'd get a full formula sheet for this. But as I said, I won't make you memorize any specific conversions except time. So you need to know 60 seconds is a minute, 60 minutes is an hour, 24 hours is a day, 365 days is a year. We don't make a statement about months or days to a month. I'm sorry, yeah, days to a month. No or there. So again, if you don't have any questions about the midterm, we're going to continue on. In the review, you will see a couple Excel-based questions in the, for the midterm. It's not anything super crazy. It's mostly about cell references, whether they're fixed or whether they're regular. You'll see some things with charts. You'll see a lot of things with proportions. Chapter 2, 3, and 4 is mostly proportions. I'd say like a third of this test is just proportions, cross multiplying and solving, but you know, you'll have to know how to set things up. All right. So with that being said, let's move on to 4.2, part to whole ratios. Please note that there is a difference between part to part and part to whole. We've already alluded to this in the past. In fact, we did that pretty early on in the semester. So what's a part-to-part relationship? What's a part-to-part comparison or ratio? If you've got 4 red dodgeballs and 5 blue dodgeballs, if you wanted to compare them as a ratio, you could say the ratio of red to blue is 4 reds to 5 blues. Does it have to be set up as red over blue? Maybe. It depends on how the problem is worded. Maybe you could go blue over red, in which case you'd say 5 blue is to 4 red. If they don't tell you the order to do it, you get to pick the order. But if they do tell you, well, then obviously you have to pick the order. I'm sorry, then if they do tell you, then you don't get to pick the order. You do it as they say. So you've got a bag of dodgeballs in gym class, and inside of that bag there are 4 reds and 5 blues. So the red to blue ratio or comparison is 4 to 5, 4 reds for 5 blues. So maybe this is just how it is for every single sack of dodgeballs. So maybe there are 12 sacks of dodgeballs in the closet. So if you go to another one, it's 4 red and 5 blue. If you go to another one, it's 4 red and 5 blue. And maybe you empty out 3 of these, and now you've got 12 reds and 15 blues, but that ratio is still 4 to 5 because of the consistency. A part to whole ratio, this would be only comparing one of the categories to the total, which above, we did not say what the total number of dodgeballs is. We would actually have to, well, add them. 4 plus 5 is 9. So you'd have a ratio of red to whole, which would be 4 to 9, 4 reds to 9 in total, or a ratio of blue to whole, which would be 5 blue to 9 total. It just depends on which one they ask you for. So your part-to-part ratios could be flipped. Your part-to-whole ratios, the numbers in the top can be different, but the numbers in the bottom are always the same. Now when you're doing this, if you have a ratio table set up, you can use it, or a proportion table, whichever you like to call that. They're both the same thing. But you'll need columns for all parts and columns for the wholes as well. Be careful not to misinterpret, and I forgot to open the textbook. So this is one of the few times I actually do want to use the e-text. Hopefully it doesn't take an hour to open. All right, zoom in just a little. Understanding part-to-part ratio. So like I said, this title of the section is called part-to-part, but we also do part-to-whole. They just didn't want to have a super wordy title. So use a percentage for a part-to-part ratio. So they say in a class, the ratio of boys to girls is 2 to 3. So because they say the ratio is 2 to 3, that means no matter how many people you have in there, this is always true. So if you had 20 boys, there'd be 30 girls. If you have 200 boys, there'd be 300 girls. If there were 4 boys, there'd be 6 girls. If there were 8 boys, there'd be 12 girls. So they say to interpret this part-to-part ratio as a percentage and compute the associated part-to-whole ratios. Trying to decide how they, yeah, they show the work on the next page, okay. So I'm just gonna throw on the annotate for a second to show you what they ask you to do here. They say interpret this part-to-part ratio as a percentage and compute the associated part-to-whole ratios. Now, they say to compute the part-to-part as a percentage, and they tell you how to do, or which way to do this, because they throw the number here. Because they put 100 here, they're basing this off of the girls being a, quote, whole if we're only looking at the parts. And that might sound a little convoluted. But what we're doing here is, okay, we got the 2 boys is 3 girls. So here's the part, here's a part, and then we make a column for the whole where if it's 2 boys and 3 girls, that means there's 5 students in total. We're not saying it's always just 2 boys and 3 girls. We're saying for every 2 boys, there are 3 girls, which means for every bit of information that correlates there are 5 total. So it could be 4 boys and 6 girls, which would be 10 students total, or 20 boys and 30 girls, which would be 50 students total. But breaking it down as small as possible, it's 2 to 3 with a total of 5. So they say interpret this part-to-part ratio as a percentage, and they're putting the 100 here. They don't have to. They could have put the 100 here instead, and we'd get a different answer. And I will actually go through and do that ultimately. So how do we solve for x here? Well, here's our box in a proportion table. We got 3 numbers and a blank, so we can cross multiply and solve that. After we set up our proportion, we go 2 over x equals 3 over 100. Cross multiplying gives us 200 equals 3x. Divide both sides by 3. And 200 divided by 3 is 66.7. It's 66.66666. We're just rounding. So that's our x. So where I have an x here, this is really 66.7. Now we're interpreting this thing as a type of percentage. That means we scaled something to 100. We scaled the girls to 100. This is not saying, this does not say the boys are 66.7% of the classes. That does not say that. This says that if there were 100 girls, there would be 66.7 boys, or 67 if you want to round to the nearest whole for that interpretation. As a percentage, you don't need that though. So this is the misinterpretation that people might make that I was referring to in the notes to share. The other interpretation that might be seen is some people might say, oh, well, 66.7% of the boys are girls. That definitely is not the answer. I think for very obvious reasons. 66.7% of boys are not girls. That is definitely true. Okay, so let me clear my screen so I can move on. Actually, I didn't want to do that yet. What's the real interpretation? What it says in reality is that there are 66.7 boys for every 100 girls, or you could say that the number of boys is 66.7% of the number of girls. That's what this says because the 100 was not in the whole column here, it was in the girls. So we're calling the girls 100%, and the boys number is 66.7 of that. So this is where you have to be careful with the interpretation when you're scaling one of the parts to 100. Now, when you're scaling the whole to 100 like here, that's another scenario. And that's what I'm going to do next. So we're going to find the B and the G. We're going to find the actual percentages as a whole for the boys and girls next. So again, this being a 66.7 when the girls was 100. So we scaled the girls to a percent, and then we found this value that says that the boys are 66.7% of the girls in terms of a number. And 2 is 66.7% of 3. All right, so now let me clear my screen. I'll put the number back up here. This was 66.7. But now let's solve for B and G. So the number of boys converted to a percentage. So there's no instruction for this part here, but that's what this is doing. This right here, we're going to scale the whole to a percent, which will actually find us the percentage of boys and the percentage of girls. That's what the B and the G will be for this now. Now, how do you go and draw your box? Where if we're trying to find B, well, we can't do it this way, can we? This wouldn't work because you got number, number, variable, variable. 2 numbers, 2 variables. And you might say, okay, well, maybe do it around here. That still doesn't work because the B and the G are both unknown. This is how we'd have to draw our box. Because then we got number, number, number. And we can find the B based on that. So we'd go 2 over B equals 5 over 100. Remember, when you do that, you're ignoring all the stuff in the center parts. You're only looking at the corners. So we're going to go 2 over B equals 5 over 100. I didn't mean to erase the box. Cross multiply, you'll get 200 equals 5B. Divide both sides by 5. And we get that B is equal to 40. So this is a 40 here. So that says that the boys are 40% of the class. That's what this says right here. I'll be able to fit everything over there, so I can take this. Boys are 40% of the class. Because the 100 was scaled in the whole, now we can say that the boys are 40% of the class. When we scaled the 100 onto the girl column, we got 66.7, which said that the boys were 66.7% of the girls' population. Now let's find the G. I'm going to switch my color. So we go to get this G here. Now you do have a number here of the 40, so you could draw this as your box. It's not the one I'm going to do. I'm saying you could do this now, but I'm using borrowed information, which is not my favorite thing to do. So instead, again, while that would work, I'm going to try to not use borrowed information, and that would be the better box. So we'd go 3 over G equals 5 over 100. Cross multiply, you'll get 300 equals 5G. Divide both sides by 5. 5 will go into 360 times, so we get 60 is equal to G. So that says that the girls are 60% of the class. Now I'm going to add in a row on this. I'm going to add a row. And in this row, I'm going to put a 100 for the boys. So this is the counterpart to the 100 for the girls. So when I put 100 into the girls column, that was considering the girls 100%. And then we found the boys relative to the girls. Now we're going to consider the boys as the 100 and see how many girls there are relative to the boys. So let me just call this Y. And then let's try and make a proportion out of this. And again, you could use the 40 and the 60. You could actually use those, but they're borrowed information, so I avoid that. I'm going to do it with these. Again, it would not be wrong to use the 40, the 100, the 60, and the y, but I'm going to use the 2, the 3, the 100, and the y. I'm going to do this over here. So we got 2 over 100 equals 3 over y. Cross multiply, you'll get 2y equals 300. You'll divide both sides by 2 to get y is equal to 150, which says that the girls, the number of girls, is 150% of the number of boys. It feels vastly different. When we talked about the boys relative to the boys were 66.7% of the girls' value. But when we flip that, the girls are 150% of the boys' value. Which one sounds better? Which one sounds worse? It depends on the context of the problem. But I guarantee you this, those people writing news articles and putting data out there for people to interpret, if they want them to think about it a certain way, they're going to pick a number that helps emphasize their certain number of way. Their certain way. Maybe you're trying to scare people and say, oh man, the girl population here is 150% of the boys. Maybe you're really trying to scare people into, oh, okay, we need the boys to pick it up because there's 50% more in the girls column. Maybe you're not trying to scare people as much because here that's only a 23% difference versus a 50% difference, so it doesn't feel as significant. Oh, okay, the boys are 66.7% of the girls. That doesn't sound as bad if you're trying to have it be split even as 150. 66.7 sounds a little better. Now, maybe you want these numbers to be bigger than 100 or less than 100 for, again, scare tactics. So maybe being better than 100 sounds good, and maybe being less than 100 sounds bad. So I'd go with the number less than 100 to scare people. I don't know. And again, maybe you're just trying to throw people off. Say, oh, it's not 40% are boys and 60% are girls. It's talking about it as a comparison to one to other makes those numbers feel drastically different. The girls are 60% of the population, but they're 150% of the value of boys. You can make numbers, when you talk about percentages compared to something else, you can make them feel certain ways to people. And when you're trying to rationalize fake news, very often this is how things are done. They'll have real numbers, but they make them as scary as possible. Okay, so with that being said, and you can see a lot of the analysis that I talked about on the next page, and if you're actually reading ahead like you're supposed to, you would have already seen all of this. They go into the wrong interpretations, they go into the correct interpretation, they do the solving for the boys and the girls, there's nothing new there. They go into more examples. So if you don't do the concentration one, that's a bit too much. But this right here, this markup, this is a great example to follow, which we don't have time to do, unfortunately. Okay. So I'll leave that up in case I need it. I don't think I do, though. Let's go to the guided worksheets. And in the guided worksheets, look at that. We literally just did the first one. It's all right there. We already completed it. Guided activity numero 1, parts of the population. The following table gives sizes of the US population on July 1st, 2017, and they give a hyperlink to that, so if you wanted to see it, you can click it, it pulls up. Oh, wait, no it doesn't. That's great. Oh, it worked last semester. That's a shame. They changed the link. Oh, that's so ironic. I kind of love it. The whole reason we have our books set up this way is for these links and such, and now it's pointless for some of it. I'm sure most of the links still work either way. The actual textbook links are fine. This is outside the textbook. So they got some blanks and they got some hundreds. So this is going to be doing the same type of thing we did before. So we have these categories based on ages. We got a category for the number of people under 18. So out of the entire population, so this top row is the entire population, there's 73 million and some change under 18. Then we got about 200 million that are 18 to 64. And then we got about 50 million that are 65 or older. And I think this makes sense that most of our population is in this age range because it's a very wide range of ages. 65, well, the average lifespan for people is somewhere between, what, 67 and 72 based on whether you're male and female. So this is when people start dropping off, unfortunately, so there's going to be less of them. And only 18 years, this is still a significant number of people. The young population tends to be the largest, again, if you break it down in 18 years, but we're only looking at 18 years instead of like 40 years here. So this total, how do you get this total? Well, you add it up. You just add the numbers. And if you do, you should get, ow, oh, my shoulder just popped. Sorry about that. 325 million, 719,178. Please confirm that. Just add those three numbers. I'm taking that as leap of faith as what I have written down. I'm assuming I wrote down the right number or previously. Then they say, okay, what we want to do is consider the other categories of population scaled. Hold on, I'm about to say something a little improperly. Let's consider these two categories, the under 18 and the 65 and over. Let's scale them relative to the 18 to 64 population. So we're going to call the 18 to 64 100%, and then we'll be able to think about these other two categories relative to the 18 to 64-year-olds. Then we flip that idea, and we're going to, I don't know why I circled that. Then we're going to say, okay, well, now let's consider the elderly the 100%, and let's get a sense of scale for the other two categories relative to them. We don't do the under 18 as 100. That's just their choice. We certainly could have. There could be an additional row. But then finally, we say, all right, let's scale the total population to 100 so we can actually say, all right, the under 18-year-olds are this percent, these are that percent, these are that percent. And I think we're going to do a couple of these, if not all. So we got to draw proportions. If we want to get this blank right here, so I'll call this A. Just got to be able to draw a box. Do you need to do this? Well, no, that would be too much because this is a blank and this is a blank. So that wouldn't work. You might say, oh, we'll do it down here. Well, these are all blanks. You're not going to do anything good there. This row is completely completed. So that's probably a good anchor to have. You probably want to do something like this. And then you could say, all right, well, how far do I need to go? Do I need to go this far? Well, there's a blank, so no. But these two have numbers. So there's our proportion table. So then we can use those, and we go the 73 million over A equals 201 million over 100. I want to erase my box, though. So we're going to go 73. I'm just going to write M for million. The rest of the numbers are implied to be there. I don't want to have to write all that. Over A equals the 201 million over 100. When you cross multiply, you'll take that 100 times the 73 million, which basically just tacks on two zeros there. So 736553780 equals the 201 million number times the A. You'll divide both sides by the 201 million number. Again, exactly as it is. And when you get your calculator, that's 736553780 divided by 201,205,121. You should get 36.6 if you round to the nearest tenth. That's our A. This is 36.6. 36.6. That's all we're doing here. So A has been completed. There's a B, a C, D, an E, an F, and a G. Now, before I move on, I want to go ahead to question 2. I wish I'd left a little more room for that, but it is what it is. They say to use each of the 4 numbers from the first column in a sentence. 1 sentence for each number and interpret them both as rates per 100 and as a percentage for the 3 rates. I'm not going to ask you to do both parts of that. You just need to say it one way. The 73 million one is kind of boring. All it says is there were 73 million. Again, with the rest of those values actually there. Children under 18 on that date. The next number, that 36.6, you could say, and I'm going to run out of room if I don't erase the other part, but that's the first number. So they're saying interpret the 4 numbers from the first column, the A, the, what did I say, C, and the E, these 4 numbers along with the 73 million number. So there were 73 million children under 18 on July 1st. Because this is a total row, you're not interpreting anything as a percentage. The second one, though, that's the 36.6, you'd say there were 36.6 children under 18, every 100, 100 was under the middle-aged people, let's say 18 to 64, for every 100 people aged 18 to 64. Or the other way you could say it is that the number of under 18-year-olds, the less than that means under 18-year-olds. The number of under 18-year-olds, I'm abbreviating. The number of under 18-year-olds is 36.6% of the number of, let's just say, elderly. Those are the two ways you could answer. So I'm leaving 2 of these available. I'm leaving the answer for C and E available in part 2. This is going to be your discussion board for the weekend. So the discussion board for the weekend is 1, 2, 3, 4, 5, 6. You've got 6 blocks to fill out here, and then 2 blocks to fill out here for your interpretations. So your discussion board. Okay, because that is going to work. Because I can't actually see it as I'm typing it. It's kind of scary. Maybe if I do this first and then change it. 1 student each, and this is page 162. Find B, C, D, E, F, G. Then 1 student each. Question 2. Write a sentence using C or E. So that's your discussion board. So 1, 2, 3, 4, 5, 6 people can come in and do math. And then once those numbers are in place, particularly once C and E are in place, then 2 students, one student does C, one student does E, can make that sentence. Where'd it go? Oh, I bet I whited it out. Yeah, you saw it though, it's in the recording. But it would be based, you'd have a sentence and you can just do one of them. You don't have to do both versions. You can do it as a percentage or you can do it for every this many, there's 100 of the other thing. Now, some of these are based on a part, some of these are based on a whole, so make sure you interpret correctly. If someone types a message and someone else comes in and says, oh, I don't think that's correct, then you can make a statement in the thread and say, well, no, it would be this. But again, participation is key, so please do that. How are we doing on time? 10 o'clock. All right. So 4.3. Nope, wrong file. Actually, one minor little detail that we did not discuss. This. And I think the first part is super obvious. If you're given 2 parts to find the whole, you add up the 2 parts. If you're given 3 parts, you add up the 3 parts to find the whole. All those are true. That's actually what we did to get the 9 total up here. But what might not be super obvious to some people is that if you only have 2 parts, you can take the whole. If you know part 1, you can subtract those 2 things to find the second part. For example, if I told you there's 9 total and there's 4 reds, and then I ask you how many blues are there, you do 9 minus 4 to get 5, and that's the 5 blue. Or I could tell you there's 9 total and there's 5 blue, how many reds are there? 9 minus 5 is 4, so there'd be 4 reds. If you have 3 or 4 or 5 parts, then you have to know all of the number of parts except for 1. It's just the whole minus all the parts would give you the last remaining unknown part, but you can only not know one of the parts. So this is an important idea to understand because all parts add up to a whole. You can take a whole and subtract all but one part to get the remaining part. And that finishes 4.2. All right, 4.3. Let me just bump this down. There we go. Percent change and difference. Now, this is still a ratio, but inside of the ratio, there's a little bit more going on. So percent change is a lot harder to interpret as a proportion because of that. Because percent change is the change relative to an original value. That's the concept of percent change. But where it says total change in this little quote formula, you're not necessarily going to be told to change. You might have to figure out what that is. Change is a difference when we look at this as a comparison to old versus new. Let's say you have 2 apples on Monday and then you have 8 apples on Tuesday. What was the change? Well, you went from 2 to 8. The change would be 6 because 8 minus 2 is 6. That's the idea of change. Change is a difference unless we're talking about it as a percent. When we talk about it as a percent, then it's relative to the original value. So when we just say change, like total change, and we could just say change, you don't have to say total change. If I just say change, that's a difference. It's the difference of the new and the old, and it's always new minus old, or new minus original, however you want to phrase that. Now, most of the time, when we talk about changes, we're talking about time. We know this thing happened first and this thing happened second. It was 2 on Monday and it was 8 on Tuesday, something like that. But we can actually compute percent changes not based on time. It could be, all right, there's 2 apples and 7 oranges. What's the percent change relative to oranges? Or what's the percent change relative to apples? You have to be then told which one counts as the original, basically. Which is exactly like scaling something like a category of 18 to 64-year-olds to 100 or under 18s to 100. All these ideas are fluid. 1 second. Okay. So change, what is change? Change is a difference. Now change can be positive or negative. If you go from 2 apples to 8 apples, that means you gained 6 apples. The number of apples increased by 6. That would be a positive change. Flip the script, if you have eight apples on Monday and 2 apples on Tuesday, that means you probably ate some apples or threw them away because they were rotten, whatever. It's not like you went to the store and bought more. So you went from 8 to 2, that's still a change of 6, but now it's a negative 6. It's a decrease in this case. So change can be up or down. It depends on the problem. Okay. Total change is a difference. Percent change, whether you use the word or the symbol percent, is a relative difference. This is another case of media loves to throw around percent changes because it can be very easy to cause people to misinterpret this. And we'll get into that idea later. So percent change is relative to the original value. So not only are we looking at the difference, that's still part of the idea. You still have to have the difference there. But now, because we're scaling it to the original value, we're not scaling it to 100, we're scaling it to the original value. So instead of dividing by 100, we divide by whatever it was originally. So in that example of going from 2 apples to 8 apples, the change was 6, and we would divide by the original, which was 2. So if you went from on Monday, 2 apples. On Tuesday, 8 apples. That says the change is 8 minus 2, which is 6 apples. Now, some people actually like to write that plus sign there to denote that it's a positive change, it's increasing. That's the actual change, or total change. The percent change is this difference, the total change of 6 apples, relative to the original number of apples, which was 2 apples. You have to know which one to divide by. We're not dividing by 8 because 8's what happened later. We always divide by what occurs first. Percent change is relative to what it was originally. Think about it this way. If you get a pay raise, if your boss says you get a 2% pay raise, is your pay raise going to be based off of your current salary or your future salary? It's based off your future salary. And that 2% is literally a percent change. Now this percent, when you do this problem, 6 divided by 2 is 3. The apples cancel, so you just get 3. So is the percent change 3? That sounds really minuscule, 3% increase, but we went from 2 to 8. That sounds significant. And that's because it's not a 3% change. This is a whole number. This is a decimal number that you must convert to a percent. Look at this, all caps right here. Convert that to a percent. So that 3 becomes 300%, and that's an increase. There was a 300% increase in the number of apples we have from Monday to Tuesday. That's what's being said here. Now, what some students would then do is they'll raise their hand and go, Mr. Beckner, 8 is 4 times 2. Why is this not a 400% increase? And then I go, that's a great question, Bob or Jane or Alex or whatever. Because this is the increase. This doesn't account for the 2 that we already have. The 2 that we already have is the 100%. So every 2 apples is 100%. So going from 2 to 4 is another 100%. Going from 4 to 6 is another 100%. Going from 6 to 8 is another 100%. So going from 2 to 4 to 6 to 8, that's 3 of those 100%, which is why it's a 300% increase, not a 400% increase. Yes, 8 is 400% of 2, but when we talk about it as an increase, we're only looking at the change. So the 2 that we already have is the initial 100%. The extra 6 that we get is the extra 300%. So now we actually have 400% of the original, but the change is 300%. So again, very easy to misinterpret if you're not well practiced and versed with this stuff. These are formulas, arguably. I call them concepts personally. Change is a difference. Ooh, that's a big crazy formula. Percent change is a ratio. Wow, we've never seen ratios before. Percent change is the relative difference to the original. Some people might want to write this formula more expanded. They'll go new minus old divided by the old, and then they'll say then convert to a percent. It's okay to do that. But I like keeping these as simple ideas. So I keep the change as one thing and then the percent change is another thing. Okie dokie. So let's get into this example, which is very similar to the one we just did. Last year, Mr. Beckner had 20 students in his 11 a.m. Tuesday, Thursday class. This year, he has 30. So this was talking about my fall and spring classes. We only have 8 or 9 students. Big drop. What is the total and percent change? So the total change is the subtraction. That's it. The total change is just the new minus the old. If you do these backwards, it's wrong. So you've got to understand which thing happened first in time. Well, last year sounds like what happened originally. So last year, there were 20 students. That's the old or original. Old, original, some O word. This year, that's more recently, he has 30. That's the new. So the total change, the new minus the old, that's 30 students minus 20 students. It should be 10 students. Labels are important. 10 what? 10 apples? 10 Bob Doles? $10? 10 students. And again, some people like to write the plus here. In my math lab, please pay attention to whether they want that or not. I have actually seen it done both ways, where they want the plus written and when they don't want the plus written. So instead of writing a plus 10 students, what some people might say, it's an increase of 10 students. We went from 20 to 30, that's an increase of 10. The percent change, this is the change relative to what we had originally. So again, that formula is the total change, which we just found. You can't do percent change until you have total change. So it's the percent change, I'm sorry, it's the total change divided by the original. So this is going to be a fraction. And it's the total change, which we just calculated as 10 students. Use your words, put the number up there as well. 10 students divided by the original. Now, what happened first? Was the original the 20 students or the 30 students? This is where you have to be careful. It has nothing to do with the size. Some people might think, oh, you always divide by the smaller, always divide by the bigger. No, I never said that. I never said anything about size. I said divide by the original. The original was the 20 students. So we divide by 20 students. 10 divided by 20 is 0.5 or 1/2. The students, the units cancel, so we get a half. So the percent change is a half. Well, that's 0.5. Nope, that's still not the answer, because it's supposed to be percent change, and you don't just slap a percent symbol on here. That would be wrong. You just have to convert it. 0.5, move the decimal right twice, that's 50%. I also like to see that it's an increase. There was a 50% increase in the number of students from last year to this year. I could even do this for now. So let's say, example 2. Last semester, Mr. Beckner had 30 students. This semester, percent change. So the total change would be the new minus the old. The new is the 9 minus the old 9 students, minus the old was the 30 students, and 9 minus 30 is negative 21 students. So that's a decrease because it's negative. We decreased the number of students in the class from 30 to 9. So I lost 21 students. The percent change that's a fraction because percentages are fractions. But we're not scaling the whole thing to 100. We do that at the end. First, we have to scale it to the original. So we take the total change, which was the negative 21 students, and we divide it by the original, which was the 30 students. The students cancel. Negative 21 divided by 30 is 0.7, so that's negative 0.7. But converting that to a percent, that's negative 70%. So that's the change, which means it was a 70% decrease. You don't want to throw the negative in there and say decrease. That would be a double negative. So you just say minus 70% or you say 70% decrease. Now what I want to do is I want to go back to example 1 and I want to flip the script on this. Just swap the order of example 1 occurrences and observe. Analyze, compare, answers. Spell appropriately. My degree is not in spelling. A-N-S-W-E-R-S. Why is that wrong? Ignore. Probably the possessiveness of it. It was weird. It went away automatically. I didn't click anything. Whatever. All right, so now we're going to say, instead of 20 being the old and 30 being the new, we're going to say that the old is the 30 students, the new is the 20 students. So let's just say I went from 30 students to 20 students instead of from 20 to 30. So that means the total change would be the new minus the old, which is 20 students minus the 30 students, which is negative 10 students. One of that we'll compare soon. The percent change, that's the fraction. We take the total change of the negative 10 students. We divide by the original value, which now the original was 30. 10 divided by 30 is a third, so that's negative 1/3. The students cancel, which would be negative 0.33333, which converted to a percent is negative 33.33%. Or you could say a 33.3% decrease. Now we're going to compare. We're going to compare the total change, which was the 10 student increase, to the total change here, which was a negative 10 students. Notice that the absolute value was the same. Going from 30 to 20, the change is 10. Going from 20 to 30, the change is 10. But one of them is positive, one of them is negative. So that just shows whether it's an increase or a decrease in students. So the total change, no matter what if you swap the order of a new and an old, The total change in absolute is the same, but it goes from an increase to a decrease or vice versa. But look at the percent changes. Look at this. The percent change when we went from 20 to 30 was a 50% increase. When we went from 30 to 20, it was a 33.3% decrease. This kind of feels like when we were talking about the boys in comparison to the girls and then the girls in comparison to the boys. One way it was these guys are 66.7% of the number of girls, but then when we swapped the comparison, it was 150% of the value of boys as the girls. The same idea is happening here because it's based on what you're relative to. Going from 20 to 30 is a 50% increase, but going from 30 to 20 is not a 50% decrease. It's only a 33.3% decrease. So percent change, the fact that it's relative to the original, has an effect on the numerical value. When the original is smaller, the percent change is bigger because the smaller a denominator, the bigger an output. We've done that analysis. When the percent change has a bigger bottom, it makes the actual percent change smaller. Again, we've done that analysis, that what if analysis. Back when we played with a fractions top and a fractions bottom only. That's what I'm saying here. So this is something that you can use to cause people to misinterpret. What would you rather talk about? If there is no order of new and old, if you're just comparing apples and oranges, you can say, all right, it's the apples are 50% of an increase over the oranges, or the oranges are a 33% decrease over the apples. Which one do you want the media to take in? Do you want the bigger number or the smaller number? Do you want something to sound scary or calming? So there's choices that people can make when they're talking about percent changes when there's no relative time. That's what I'm getting at here. All right. We only have a few minutes left, so I think I'm just going to get to the arrow notation, and then we'll save this growth and decay stuff for next time, which is super important. So this will be the first thing we do next time. Please read ahead. So we're going to finish about half of 4.3 today. I think we'll be able to finish 4.3 and 4.4 next class. I think we can. Arrow notation from text. This is what I'm referring to. They will have, and let me take my orange marker off. I don't like that color too much unless I have to. This is what arrow notation is in the text. They have an old value on the left. They have a new value on the right. Now, this is automatically assumed. If you have two numbers and then an arrow pointing between them, the original is always on the left, the new is always on the right. It's never something else. So if I write the number 5 and then 10, that implies that the old is the left and the 10 is the new on the right. And then you'd have an arrow pointing between them. Then there's also some writing above these. Above them would have the total change, and below that, this is not a fraction, this is just an arrow, it's kind of weird. The number below this would be the percent change. Now, as long as you have two of these pieces of information, there's 4 numbers here. You have an old, a new, a total change, and a percent change. That's 4 values. As long as you have 2 of those values, you can find the other 2 mathematically some way. The ones that we're going to focus on are finding we'll be given the reds and trying to find the blacks in terms of ink colors here. So at least at first, I'll be giving you the old and the new, and you'd have to find the total change and the percent change. Now again, when they use this notation, they don't write any of that stuff. It's automatically implied. This is the arrow notation that you have to memorize. It isn't a homework problem or 2. It could be on a test problem. So please make sure you understand that the old goes on the left, the new goes on the right. The total change is above, the percent change is below. So going from 5 to 10, if you do that math, that says the old's 5, the new is 10. That means the total change, I'm abbreviating, is 10 minus 5, which is 5. And in this notation, they do typically write the plus 5 instead of just a 5. So by writing a 5 above that, that's implying that the total change is going up from 5 to 10. It's a plus 5. the percent change calculation, PC percent change, that's the total change, which is this number here, the positive 5. And we're dividing by the original, which would be the number on the left, the old, the 5, which is a 1, but converting that to a percent is 100%. Now you might see some of these where they're given all 4 and they just ask you, say, hey, what does the plus 5 on the top mean? Or what does the 100% on the bottom mean? And again, they tend to write the plus for those as well, signifying that it's an increase. So this went from 5 to 10, it doubled, which means we gained 100% of the original. We gained 5 of whatever these things are, Mentos maybe, which means there was a 100% increase in our number of Mentos. I never wrote any units, I just wrote numbers. So again, primarily you would be given the red information and be asked to find the black information, but there are ways to do this otherwise. Check this out. If I give you the original, let's say the original is 10, and I say that there was a plus 5 here, I could actually go and ask, what is the original and what is the percent change? Well, we went from something, we added 5 and we got 10. It's actually just backwards because that's a plus 5. You take the new and you subtract it. You take 10 minus 5 to get 5 because this is a plus 5 working backwards, you subtract it. It's like an algebraic equation. So because this is 5, that says that the original is 5. And then now that you have the total change and the original, you could divide those two things to get this, and you get the 100 as well. So we're going to call it a day there at 10:24. Let's pull up our homework notes and everything. So we finished 4.2. So that's going to be due in a week. What's that, the 2nd? Yes. 4.2 due on 7/2. 4.3 we did not finish. So we'll finish that on the 30th, which means it'll be due on the 7th. All right, so 4.3 and hopefully 4.4 we will finish next time. Make sure you get all your work done. Make sure you check out the project and everything. As I said, I'll have all the discussion boards, projects, everything loaded no later than 5 p.m. I'll get it in as soon as I can, though, hopefully by 2 p.m. I anticipate everything to be done by 2 if I can't do it before 11. All right, email me if you have any questions. Have a good day. Have a good weekend. Work hard. Put in your 8 or 9 hours for this QR class. Keep working hard. Keep pushing forward. I want A's and B's in this class out of y'all. A lot of y'all are doing great. Keep working hard. Take care.